The famous American writer Ursula L. Le Guin in one of her works said through the mouth of a character, in order for a word to sound, there must be silence, before and after the word. This phrase speaks of the birth and death of the entire being. Every object in the universe has a beginning and an end. Some elementary particles exist for barely measurable fractions of seconds. Microorganism from a couple of hours to several days. A person lives for decades. Even stars that can shine for millions and billions of years eventually fade away. But what about the universe itself? Will she ever die too? If so, how will this happen? And what will happen after her death? The earliest theory of the origin of our world was the theory of a stationary universe. According to it, our universes have no beginning and no end. It has always existed and will exist forever, being in an equilibrium and stable state. However, quite quickly, observations and calculations showed that this theory is unlikely, since there are processes in the universe that are irreversible by nature. In the 10s and 20s of the 20th century, a theory widely known as the Big Bang Theory began to emerge. Currently, it is the most developed scientific theory that explains the origin and evolution of the universe. Dozens of scientists contributed to the creation of the Big Bang Theory. It is based on the work of Albert Einstein concerning the general theory of relativity. The main conclusion from this theory is the assumption that the fate of the universe depends on dark energy, the theoretical type of energy that causes the expansion of space. However, nothing definite can be said about the essence of this physical phenomenon. There are many theories, each of which has advantages and disadvantages. According to modern data, the age of the universe dates back to the time of the Big Bang and is just under 14 billion years. The universe is constantly expanding, and depending on the density of dark energy, it will either expand forever at an ever-increasing rate, or the expansion will gradually slow down and reverse. In this case, the universe will collapse back into an infinite small singularity similar to the one from which it was born. Modern developments in science do not allow us to give a definite answer to the question which of these possibilities is more likely. Based on them, we can imagine two equally probable scenarios for the development of events, called the Big Rupture and the Big Compression. The rate of expansion of the universe depends on the distance between objects and occurs the faster the further they are from each other. Imagine a balloon filled with air with two dots marked on it. If the balloon begins to inflate, these marks will begin to move away from each other. This is roughly how you can imagine the expansion of the universe. The space itself is expanding. The further apart the points are initially drawn, the faster they move away from each other. At a certain distance, this speed exceeds the speed of light. This threshold is called the event horizon. All objects located behind it disappear for the observer. It is impossible to interact with them, they cannot be observed. Just imagine that first, distant galaxies and their clusters will disappear from the sky. And then, one by one, the stars of the Milky Way will go out, starting with those farthest from the Sun. A gloomy picture. If the Big Gap theory is true, the expansion rate of the universe will constantly increase. This will lead to the fact that gradually expansion forces will begin to prevail over gravity. First, a cluster of galaxies will collapse, then the galaxies and star clusters themselves. Then star systems will disintegrate. The luminaries will no longer be able to keep the rapidly fleeing planets and satellites close to them. The next stage will be the disintegration of matter into atoms, and then the atoms into elementary particles. Matter will cease to exist. After this, the modern laws of physics stop working, and what will happen next is impossible to predict. Modern observations show that space is expanding. And the speed of this expansion is increasing. But we know nothing about the essence of dark energy, so it is possible that the process may be reversed, and the universe will begin to shrink. For example, this could happen if the total gravity created by all the matter in the universe exceeds the force of its expansion. This scenario of events is called a big compression. In this case, the processes in the universe will proceed approximately the same as now, until its size decreases by about 5 times from its current size. A cluster of galaxies will merge into one supercluster, occupying the entire universe. But within the galaxies themselves, stars will also be born and die, planets will form, and other events will occur. When the universe shrinks another 20 times, its volume will be only 1% of its current volume, and all galaxies will merge into one. The temperature of the cosmic microwave background radiation will reach 274 Kelvin and will continue to rise. This means that soon there will be no liquid water left in the entire universe, necessary for biological life. In any case, in the form familiar to us. Further compression of space will lead to even greater heating of the universe. The planets will be scorched and then melted. All matter will be crumpled into a huge cloud of boiling plasma. Then atoms and elementary particles will fall apart and, ultimately, the universe will collapse into a singularity similar to the one from which it was born. There is a theory that is a development of the big compression theory. It's called the Big Bounce theory. According to it, after the universe collapses into a singularity as a result of the big compression, it will be born again, in the next Big Bang. These events will happen again and again, presumably forever. As far as we can talk about eternity beyond space and time. It is difficult to say how long any of these scenarios will take to develop, too little is yet known about dark energy. It is possible that a big rupture or a big contraction will occur during that period of development of the universe when stars and planets will still exist. But what if not? What will happen to the universe if at the moment of the final death of the universe, it is very distant in time? Still, the laws of physics are such that the universe we are familiar with cannot exist indefinitely. There are 4 extended cosmological eras, each of which has its own face. We live in the so-called age of stars. The universe around us still contains abundant reserves of interstellar gas, the raw material from which stars are formed. New stars continue to be born, and this process will not end until all interstellar gas is exhausted. This era will end in a period of time from 1 to 100 trillion years. During this time, the Sun and the vast majority of other stars will exhaust their reserves of nuclear fuel, and will turn into white dwarfs, neutron stars or black holes. The next era is called the era of decay. By this time there will be no more main sequence stars. Most of the matter in the universe is concentrated in white and brown dwarfs, leaving some for neutron stars and black holes. All of these objects will slowly cool over a very long time, on the order of 1 dodecillion, or 10 to the 39th power of years. White dwarfs gradually release their accumulated heat into radiation and turn into black dwarfs. Brown dwarfs will also cool down and the sluggish thermonuclear reactions in their depths will finally cease. Gradually, most of the matter will be absorbed by black holes. At this stage of the development of the universe, the main processes will be the angelization of dark matter and the decay of protons. Protons are the elementary particles that make up all the atoms we know. They are considered one of the longest-lived elementary particles. The estimated lifetime of a proton is about 100 dodecillion, or 10 to the 41st power of years. Thus, by the end of the decay era, matter in the universe should be a sea of scattered elementary particles, among which individual neutron stars and black holes remain. The next era is called the era of black holes. According to some theories, they will gather in a cluster and merge with each other until they form a single giant black hole. According to other theories, black holes will slowly evaporate, emitting energy until they finally disappear. Black hole evaporation is a quantum effect caused by Hawking radiation. The smaller the black hole, the more intense it is, and ultimately deprives the whole of all its matter and energy. This process will end presumably in 10 to the 100th power of years. This number is called a googol. Be that as it may, in the end, only dead space will remain in the universe, filled with residual products of processes that occurred in previous eras, photons and electrons, positrons, neutrinos and quarks. Electrons and positrons gradually annihilate each other. In this form, the universe can theoretically exist indefinitely, at least until a major collapse or major collapse. In any case, humanity will not live to see this moment. Most likely it will disappear in the era of stars. Our planet will be habitable for about 1 billion more years. Then she will be burned out by the gradually warming sun. And in 5 to 6 billion years, our star, which by this time has become a red giant, will shed its outer shells and turn into a white dwarf. But what will happen after the death of the universe? It is unlikely that an answer to this question is possible, because after the death of the universe, no matter what scenario it occurs, there will be neither space nor time in the understanding available to us. Even if the Big Rebound theory is true and after the Big Compression there will be a big new explosion and a new universe with its galaxies and stars, then we will never know about it. How can we not find out about the previous universe? The one that was before ours? After all, for a word to sound, there must be silence, before and after it. Feel free to express your opinion about this video by clicking like or writing comments under the video. And if you want to continue to get acquainted with educational and interesting material on our channel, subscribe. Your support is very important and helps us develop, delighting you with new videos. And we will hear you.